Hello, my name is Francisco Forster, and I'm talking on behalf of the ALeRCE broker. The ALeRCE broker is one of the 7 community brokers of the Beta Rubin, and as you may have heard, it's an interdisciplinary collaboration that involves several institutions in Chile and also some in the US. We have a very interdisciplinary team that is composed of astronomers, computer scientists, electrical engineers, mathematicians. As you know, the future time domain ecosystem is going to be composed of several layers. So first, the survey telescopes, among them the Rubin Observatory, and that basically are going to be surveying the sky and detecting things that change in the sky. Those things that are more interesting will be followed up by follow-up telescopes, but in order for them to identify the most interesting objects, community brokers are going to become intermediaries between the survey and the follow-up telescopes. Community brokers will also connect the survey telescopes with the downstream brokers and TOMs, as well as the general user community. The products and services offered by brokers are many. Here I compile a list of what we have seen that is evolving with time. So initially, brokers were just supposed to receive an input stream and output an output stream in Kafka, with adding certain information or filtering or classifying. And as time has passed, brokers are including many more services. For example, cross matches, watch list, detection of outliers, etc. The scientific questions that define ALeRCE are basically 4, and are in these 4 main lines: questions about transients, variable stars, active galactic nuclei, and solar system objects. We have a special focus on the first 3 in this list: transients, variable stars, and active galactic nuclei. The ALeRCE user community has grown significantly and now includes researchers or general public from 129 countries. So these are the countries where there has been at least one user accessing the ALeRCE services. Because we are submitting the best supernova candidates every day from CDF, we have become the second group to have submitted more transients to the transient name server. And of the classified, spectroscopically classified transients, we are the 3rd group that has reported the original candidate first. ALeRCE is currently processing data from the Zwicky Transient Facility and ATLAS telescopes. So in the public website of ALeRCE, you will only see the CDF alerts and processing. But we have a version of ALeRCE in staging that is also processing ATLAS. What we do to process these 2 streams is to have a pipeline that's composed of several steps. Among them is a sorting hat step that combines and cross-match in real time the 2 streams. Then alerts undergo different treatments. So in one branch, we build light curves and we classify them. And in parallel, we do also the classification of the image stamps. This is for fast classification. So we have 2 main classifiers: the stamp-based classifier that provides, with a simple taxonomy of 5 classes, a very fast classification of objects with just 1 detection. And this has allowed us to submit very good candidates to the transient name server very rapidly. And a more refined taxonomy and classifier that is based on the light curve that includes 15 classes and can be used for or post-processing and analysis of the whole population of events. Both are available in our web interfaces. So the main web interface is the ALeRCE Explorer, and here you can quickly query, for example, using the light curve classifier, all type 2 supernova, and see all the metadata, the light curve, machine learning classification probabilities, image stamps, contextual information from Aladdin, and cross-match information. For example, in this case, you can get the redshift of the galaxy. You can very quickly move between candidates using just the keyboard. So this has been designed to be very easy to use, very intuitive. And I would say it's becoming kind of a standard of how you can present these candidates. The other tool that ALeRCE has provided is the Supernova Hunter. In the Supernova Hunter, you can quickly search for the best supernova candidates from the last 48 hours you decide, to quickly inspect these image stamps and basically be able to determine whether something is a likely supernova or not, or transient, extragalactic transient. We have other services. So we have an API that is open. You can access, basically do queries to the database through the API and do, for example, getting the probabilities, machine learning probabilities, classification, features. And we also have an API to access the CTF data release information associated to a given part of the sky. And all of this is also included in a Python client that is built to make the API queries easier. We can also, with the client, you can do complex queries, for example, defining the classifier, the probabilities, the number of detection, etc. And for more complicated, sophisticated queries, we can also provide direct access to the database, which is in PostgreSQL. Currently, this has a limit of 2 minutes per query. But if you want to do more complex queries, you can ask for access as well. We have many other services that I'll just highlight here. So the watchlist service, where you can submit a list of coordinates in the sky and get notified every time there is a change in these coordinates. You can access all the features that we have built, and here's the detail of what they are. We have integrated data release information into the Explorer, so you can see one example in this object. We have provided many use case notebooks built around different science cases with astronomers. We have we can provide a tool to automatically identify host galaxies. This will be soon integrated into the Explorer, but this you can pip install with the Astro Delight. That's the name. You can also, we are also reporting candidates to TNS, including host galaxy information and the redshift when available. You can here see some statistics. And we are participating in the Elastic Challenge. And so far, according to the information that is provided, we have the best accuracy, F1 score, recall precision, and overall completeness. So because of Elastic, we developed a new family of models using a different architecture of transformers, which we have submitted for publication. And here you can see the confusion matrix that we achieved with the training set provided by the Elastic collaboration. So ALeRCE is evolving all the time. We're now transitioning from CTF only with PostgreSQL to CTF and Atlas, which is in staging now using MongoDB, which is a non-relational database, and then to Rubin, continuing with MongoDB, most likely, and scaling to larger servers. Under development, there are many things happening that you don't see. Some are shown here. We are working on load balancing to make sure that all the services are scaled up in infrastructure as when they are required. We are changing the way we interact with the database to make updates to the database faster. So with asynchronous updates in batches. And we are working on new models that do multi-stream classification, not just with CTF, but CTF and Atlas. And here you can see a list of publications and different links for you to test and ALeRCE and learn about what we can offer. And finally, I would like to make an announcement. We are organizing a conference which will happen in December of this year, most likely the second week of December, which is going to be called Unveiling the Dynamic Universe, Cosmic Streams in the Era of Rubin. The idea here is to bring together all the broker community, in terms of users, but also builders. And it will be held in Puerto Varas in the Lake District in Chile, a very nice area of Chile. And we plan to visit some hot springs, as well as having very interesting scientific discussion. So I really hope to see you there. After the pandemic, we really need to start meeting in person again. So thank you very much.